Okay. So in this lecture, we will going to talk about the frequent use semiconductors. When we are talking about the commonly used semiconductors, so we have got a most popular materials, and the most popular material used are the germanium and the silicon. Okay, so we can say that the two most frequently used semiconductor materials are my germanium, that is the GE, and silicon, Si. So the reason of germanium and silicon to be more popular is because the energy required to break their covalent bond is very small. So I'm writing because the energy required to break their covalent bond is very small. That is, we are talking with respect to the energy required to release an electron from their valence band, and that should reach to the conduction band. Okay, so we are writing it, energy required to break the covalent bond is very small. So I'm highlighting this very small because when we are talking about the very small, we are talking about the energy. Okay, so we are writing the energy. What is the energy required? So we say that for germanium, we required zero point 0.7 electron volt, and for silicon, we required 1.1 electron volt. So now for the example, we will going to consider the silicon. Okay, so let's consider the silicon. And when we are talking about the silicon, we say the atomic number of the silicon is 14. So let me write it. The atomic number of silicon is 14. So the atomic number 14 means that the silicon will have 14 protons and 14 electrons. So I'm writing it has got 14 protons and 14 electrons. Now we will going to see the orbit configuration. Okay, so let us write it. So with respect to the orbit configuration, we can say that it has two electrons in first orbit, then it has got 8 electrons in the second orbit, and 4 electrons in the third orbit. So from the third orbit, we can say that silicon atom has got 4 valence electrons. Okay, so we can write that atom has 4 valence electrons. Therefore, we can define that silicon is also known as the tetravalent element. So I'm writing it tetravalent element. Now we will going to consider the germanium. So we have already seen the example of a silicon. Okay, and we have seen that has got in their last orbit we have got a 4 valence electron, and now we will be considering the germanium. So when we are talking about the germanium, we say that the germanium has got a atomic number of 32. So when we are saying the atomic number 32 means it has got 32 protons and 32 electrons in it. So now we will go for its orbit configuration. So it has got 2 electron in its first orbit. So I am writing 2 electron in first orbit, 8 electrons in the second orbit, 8 electron in the second orbit, 18 electrons in the third orbit, 18 electron in the third orbit, and if you do the calculation, we have remained with the 4 electrons. So 4 electron in the outer or the balance orbit. Okay, so we are writing outer or the balance orbit, or we can say it is a fourth orbit. So again, we can say germanium has also got the 4 valence electrons, and therefore it is also known as the tetravalent element. So I'm writing it. It is known as the tetravalent element.